Hello students, this is Mr. Boyd. Welcome to today's lesson on properties of exponents. We're going to start off with the negative exponents, but we will probably review those rules that we did yesterday and the day before, the product rules. But let's go ahead and dive in here. So you need a sheet of paper out. You need to take notes on this as we go along. So the properties of exponents, first of all, an exponent is considered repeated multiplication. So if we have something like 3 to the 5th power, that would mean that this 3 is going to be multiplied by itself 5 times. Okay? Whereas multiplication is repeated addition. What this stands for is that we have the two added together 3 times. Okay? So the difference between multiplication and exponents is that multiplication is the shortcut is the shortcut for notating repeated addition. Exponents is the repeated multiplication. We call this number up here the exponent or power, and that tells us how many times that factor is going to be repeated. This big number, or the bottom number, is called a base, and it's the factor that's repeated each time. Now on the left-hand side, this whole thing is what we call exponential notation or exponent notation. This stuff on the right-hand side is what we call expanded notation or expanded form. Okay? So let's roll on down to our first example here in rule. So in this first rule, we're looking at what happens when we have a negative exponent. So I see here I've got a negative exponent on a base of b, and what happens is it flips over. It gets its reciprocal. So if I was to put a 1 under this, notice that this whole thing just flipped over, and when it flips over, the exponent becomes positive. Same thing is true here. Notice that the negative exponent is in the denominator this time. Okay, and when it flipped over, when this fraction flipped over, this exponent became positive. So let's take a look at these two examples here. So I've got 5 to the negative 3rd power. Well, if I put that over 1, then to make this exponent positive, because answers can never contain negative exponents. So what we want to do is flip this over. We call that a reciprocal, and we'll make the power positive. Negative exponent rule gives us a reciprocal. Okay? Let's take a look at example B. Notice that the negative exponent is in the denominator, so that tells me that these two are going to switch places. Now, only the negative exponent switches places. So if we put the negative exponent up here and make it positive, we would put a 1 under it. Okay? And then, of course, we don't have to write that with a 1 under it. We can write it just as 4 to the 2nd power. Okay, let's move on to our 0 exponent rule. So for 0 exponents, the rule is anything to the 0 power equals 1. Okay, that might not make sense to you right now, but go ahead and memorize it. Anything to the 0 power. Now, it's also important to note, we talked about this last lesson, is that the exponent only affects what's just to its left. Okay, just what's to its left. So we'll look at an example where that affects what I'm talking about. Okay, so 7 to the 0 power. Anything to the 0 power. This is going to equal 1. negative 5 to the 0 power. Notice the negative 5 is in parentheses. So that entire thing is getting raised to the 0 power. This is going to equal 1. Now, part C. Part C, the 5 is getting raised to the 0 power, but the negative is not. It's not in parentheses, okay? So this is going to give us a result of negative 1, okay? Because the negative sign is not in there. Let's take a look at an example like this, though. What if we had something like 2b to the 0, c to the third, okay? Well, if I replace that b to the 0, anything to the 0 equals 1, you got to remember that this is a multiplication problem. We don't write the multiplication symbols when we use variables because we just cram them together. Okay, so if we replace that with 1, then our answer would just be 2 times 1, or 2, c to the third. Okay? All right. So now we're going to look at, we're going to review a rule that we've already done. By the way, this G right here, I think it's supposed to be a multiplication symbol, so I'm going to just write that in. Go ahead and fill that in your notes. Okay? And so we notice that when we multiply like bases, notice these bases are exactly the same, and they have some powers up here. The rule is to add the two exponents together and keep the base. So if we fill this in, we're going to keep the base, and we're going to add the exponents. So again, this G is supposed to be a multiplication symbol. Evidently, when the computer translated this, it did not give it the right thing. So go ahead and write that multiplication symbol in there. Didn't recognize that notation. All right, so if we've got 2 to the second times 2 to the third, that would be 2. We're going to add those exponents because we're multiplying the same base together. And 2 plus 3, that's going to give us 2 to the 5th power. And if you need to see that fleshed out a little further, 2 to the 2nd power would be 2 times 2. 2 to the 3rd would be 2 times 2 times 2. And we notice that those are being multiplied together, so that gives us 2 to the 1, 2, 3, 4, 5th power. Okay? All right, so let's take a look at this one. So we've got x to the negative 3rd times x to the 7th. I notice that we have like bases, so that means I can add the exponents. So we've got x to the negative 3 plus 7, which is going to give me x to the 4th power. All right, so there's a review of yesterday's stuff. All right, so what about the quotient rule? So if when we multiply like bases, we add the exponents, when we divide like bases, we're going to keep the base, don't divide, keep the base, and we're going to subtract the exponents. Don't subtract the bases, subtract the exponents. Okay, so in this case, and let me show you how this works out. If we've got 2 to the 12th, we're going to have 12 2's up here. Oh my goodness, that's a bunch. 4, 5, 6, 7, 8, 9, 10, 11, 12. And all of these are multiplied together because exponents is the shortcut or the notation for repeated multiplication. In the denominator, we've got 4 2's multiplied together. Now we know that 2 divided by 2 is 1. So if I cross out my 1's, because 1 times 1 times 1 times 1 times 2 times all that, then I know that my final answer is going to be 2 to the 8th power. So see, we can see that that rule works out so that we have 2 to the 12 minus 4, and that's going to equal 2 to the 8th power. Notice I keep the base the same, subtract those exponents. All right? So on this one, let's just go ahead and apply our rule here. We would do x to the 2 minus 5, and that's going to give me x to the negative 3. But remember, we can't have negative exponents as an answer. So we're going to put a 1 under it, and then we're going to reciprocate it or give it its reciprocal. And that's going to give us 1 over x to the third power. Okay.